What has ultimately always stood behind our conviction that the world is a knowable and therefore controllable place is that the mathematics which governs the world said so. But what happens when that assurance is taken away? When the mathematics begins to tell us that perhaps the world isn't as predictable and controllable as we once thought, that our old assurances might be wrong.
Financial markets across the globe are in turmoil this afternoon as another big bank collapses.
And when the disasters of today begin to fuel fears for tomorrow.
There is a growing awareness of the fact that the world in which we live is unpredictable, chaotic.
One of the most powerful hurricanes on record hits the Gulf Coast of America.
Is now plowing its way.
We thought we could control everything. Now we feel we can control nothing, and that comes out of this notion that there is chaos in the world, that you can never know enough to be able to really predict it, let alone control it.
From simple models and the mathematics which control them is coming a challenge to our old worldview.
There's a simple human need to have a forecast about the future. There's a deep desire, if you like, to be able to control the future, and a very, very deep reluctance to accept the really modern advances in mathematics, which suggests that there are high levels of fundamental unpredictability.
America's mortgage crisis fears for the future of two huge companies after their shares reels from the impact of the latest hurricane. Hundreds of lives have been lost.
It used to be that our dreams of the future were a bright and open place. What happened to us that our vision of the future is no longer bright, but dark?
People are really, really hit and they're really depressed and there's nowhere to turn. Where did it all begin? You know, what's the answer? It's like it was a big design, it's a global type of effect.
Well, you have anxiety attacks, you have nightmares. Who can we blame this on? Anybody? Can anybody tell me?
The key kind of psychological experience of anxiety is a fear that something awful is going to happen, a kind of dread and uncertainty.
This film is a history of that anxiety and the mathematics which created it.
We are in the midst of a huge cultural change. Only 50 years ago, experts had a whole vocabulary for describing the world, which already sounds very foreign to us. They talked about a command and control economy, of engineering the weather, of central planning. No one today thinks the world can be described in such terms. Today, we're much more likely to talk about disorder, instability, turbulence, tipping points, the butterfly effect. This is the vocabulary which has come to us from the mathematics of the last 50 years. And it is this mathematics which is in the process of completely altering our understanding of the fundamental nature of the world we live in, and I believe is giving us a whole new vocabulary for talking about our anxieties about that world.
Looking back, we can see what was not obvious then. Those mathematical discoveries, which would eventually undermine the optimistic view of the world and set us on our way to the anxieties of today. The mathematical roots of our modern anxiety have their beginnings here, in Paris, in 1885. The city was preparing to celebrate the optimistic worldview of science and reason. There was to be a grand exhibition to celebrate progress and democracy. It was the centenary of the Republic.
And towering over it all was to be the world's tallest building, a symbol of everything that they believed in, a perfect hymn in iron to the rational and ordered worldview of Newtonian science.
Newtonian mathematics describes a place that follows clear rules of cause and effect, which make it predictable and therefore ultimately controllable. In the hands of one of Newton's greatest followers, the French atheist and mathematician Pierre-Simon Laplace, it became a set of beliefs about the nature of everything, an almost religious belief that the world could be understood as a machine.
There was this strong notion that the world should be mechanistic and deterministic.
David Rouelle is a theoretical physicist and one of the principal discoverers of chaos mathematics.
Newton and Laplace saw the world as a machine, and everybody did, to the extent that they were scientists. They wanted to have determinism.
In a mechanistic world, nothing happens without a cause. Nothing is unexplainable. In this world, if you understood the mathematical rules, you understood the world. Everything was predictable. Science could guarantee safety and progress.
So that you could have this Laplacian, what was sometimes called a sort of clockwork view of the universe, where, you know, if enough people did enough sums, then everything would be understood, because they thought they knew how systems behaved. They thought everything did, in the end, behave nicely. They knew disasters happened. They were perfectly well aware of that. But actually, they thought the mathematics would be able to explain it completely.
And this was ultimately what underpinned their optimism and ours, and made the future seem so open. But beneath the surface of optimism that the world was conquerable and controllable was an undercurrent of worry that perhaps the world was not as tame and safe as they wished to believe. Right at the heart of Newtonian mechanics was a problem which, if it couldn't be solved, endangered the whole belief that ultimately everything was mathematically predictable, because it was to do with the one thing Newton was supposed to have absolutely solved: the orbits of the solar system.
See, the genius of Newton's equations is that if you have two bodies, one orbiting the other, like the Earth going around the Sun, the equations of motion allow you to tell the exact nature of their orbits and to predict precisely where both bodies will be at any time in the future. The claim of Newton and Laplace is that you simply scale that up and you can predict everything about the universe.
Once you've got a solution, you can say to me, well, I'd like to know where that body is going to be at such and such a time. And that could be at any time in the future or any time in the past. I can just plug in the numbers, the time that you want, and out will come the answer. And it'll give me essentially the coordinates and velocity of where that body will be.
The same mathematics that governed the orbits of the planets also governed motion here on Earth. It was the bedrock of Newtonian science that if two objects began in almost identical orbits, they would continue in almost identical orbits, the difference between them never growing. So if you knew the orbit of one, you could predict the orbit of the other.
And in theory, that's fine. In practice, what happens is that as soon as you add just one more body, just three, suddenly you cannot solve the equations and you cannot predict anything.